6.3, proving quadrilaterals are parallelograms. All right, so we're going to be jumping right into some examples here. The first one say, are you given enough information to determine that the quadrilateral is a parallelogram and to explain basically yes or no, I do or don't have enough information. So number 10, again, bear with me, I'm going to do my best on these pictures of these things, but it's, you know. The ones on my paper actually look way better than the ones on my iPad. And then they give us the diagonals of these ones with these markings on here. So using our theorems, we had, I think it was like 5 different ones in here that we used. But this one would be theorem 6.9 that says that if the diagonals of the quadrilateral bisect, then the quadrilateral is a parallelogram. So by these being congruent and these being congruent, I know then that they are bisecting, and so this is a parallelogram. So I would say yes, and I'm just going to say by theorem 6.9. If you want to write out like the actual, like what the theorem says, you obviously are welcome to do that, but since you have your theorem and postulate book, you can just say the theorem number and that's fine. Just know that if you check your work in the back of the book, they're not going to say like the theorem number, they're going to actually write it out. So just be aware of that. 12. This is all of the information that they give me. So do I have enough information to know that this would be a parallelogram?
Yeah.
Yes.
How?
You can figure out the full side.
You mean angles?
Yeah.
And also they're supplementary, so both would equal 180.
Yep, so I know these two are, again, 2 different ways I could do this one. I know that both of these are congruent, and then I could find the third angle. I would need to do that before I just say that it works by the fact that the angles are the same. I would need to do 360 minus all of this to confirm that this is in fact 60, first of all. If you're going to use that method, that's fine. The one without really having to do a whole lot of work that came to my mind is to do the supplementary one where 2 corresponding angles add up to 180. If they're supplementary, then it's parallelogram. So that's probably the one I would use, but you could do it the other way. You would just need to show mathematically that you found this angle. Don't just say it's 60 without showing it, because they could have given you false information potentially. So I'm going to say yes by theorem 6.8, I think was the number. Yes. And then I'm just going to mathematically show 60 plus 120 equals 180. So that way I know that it's supplementary. Um, 14. So on this one, they put the symbols on here showing me that the 2 sides are parallel to each other. And they also tell me that they are both equal to 6. So they don't necessarily put on there the symbol for congruent, but they give me the numbers. And since they're the same, obviously I know they're congruent. So is this a parallelogram? Yes. And this one is by theorem 6.10. Opposite sides are parallel and congruent, then it is a parallelogram. Describe how to prove that ABCD is a parallelogram, use the given information. So 16, they give me triangle AXB is congruent to triangle CXD. And then I have a picture to go with it. So they've told me that these two triangles are congruent, and I'm trying to prove that this whole shape ABCD is a parallelogram. Again, couple different ways I could potentially go about doing this one, but what kind of things do I know are true about this just with my given information? I don't technically know that. What? Okay, sort of. How do you know that?
I think it's 6.4.
I'm asking because nothing is marked.
AC is congruent to AC and AD.
Okay, but again, nothing's marked. So look, I know that these two triangles are congruent. If I have two triangles are congruent, what does that mean?
Oh, wait, is it, AB is congruent to DC? Because of the way triangle congruency works or something?
Okay, yeah, so I know that AB is congruent to, what is it, DC. I know that's true by CPCTC. But that's not enough yet to help me.
Angle AXB is congruent to
Okay, angle AXB is congruent to angle
angle
CXD. Why? So I could say the vertical angles theorem or CPCTC. So I know that this angle is congruent to this angle. What else do I know about my triangles?
Sorry, can I please go
I mean, yes, that's true, but that's not going to help me. Let's think about it. Y'all were trying to use the diagonals, right? That was what you were initially trying to do to prove that this is a parallelogram. And that is ultimately what we need to do, but I don't have any markings to show that anything is congruent. Do I know that the sides are congruent? Yes, for the same reason that you said this one, AB is congruent to DC. Okay, I'm going to put that on there myself. By CPCTC, then would you also agree that AX has to be congruent to CX by CPCTC?
Yes.
Okay, so AX is congruent to CX. And yes. So I really didn't need the AB is congruent to DC, but since y'all were on that track, I just let you go with it. So I would want to say AX is congruent to CX and BX is congruent to DX by CPCTC. Because this is true, that means then that the diagonals bisect. So, ABCD is a parallelogram. In my opinion, that's probably the hardest thing in the whole thing. So don't stress over that one too much. What value of x will make the polygon a parallelogram? So 18, we have my parallelogram. They've put markings that those two sides are parallel. And then they have x and 2x here for my angles. And that's all they give me. And they want to know what value of x would make this a parallelogram. So any idea how I would set up to figure this out?
X plus 2x equals 180.
Yep, so if these two angles add up to 180, then that would tell me that this is a parallelogram because consecutive angles are supplementary. So x plus 2x equals 180. 3x equals 180. Divide by 3. So x equals 60 degrees.
Angles are also parallel. We know it's at the bottom too.
Yeah, once I've shown this, then I know that obviously opposite angles are also going to be the same thing and all that. But all right, questions on any of that before we move into the stuff where they're giving us vertices? Nope. Okay. So stuff like 21 through 26 are going to be really good types of quiz questions, quiz test questions. I'm not saying this other stuff isn't, but can pretty much guarantee something like what we're about to do is going to be on the quiz. Do you have an AirPod in? All right, give them to me, and that probably tells me you have a phone, so give me the phone too. All right, so for 21 through 24, I'll use the same set of vertices, and we're going to be finding the different, what's it called? Different methods to solve the same thing, but that way you're just using the same one. So they give us A is -1, 6, B is 3, 5, C is 5, -3, and D is 1, -2. And we're proving that A, B, C, D is a parallelogram. Now, it doesn't matter which place you, well, it does matter where you put these, but for the sake of this, I'm not going to plot the points. You could plot them on a graph if you wanted to. But I don't really need to do that unless you just need the visual. But typically, we've got A, B, C, and D like this around the parallelogram. That tends to be the way that they go about it when they put letters on there. And approximately this is what would happen. They're not going to put like A and C beside each other and stuff like that. But again, if you want to plot them and verify where they go, you're more than welcome to do that. For the sake of time, I'm not going to, because I trust by this point in your life you know how to plot points. So 22 tells us to use theorem 6.9. And that one is the theorem that says if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So that means I'm looking for the diagonals. So my little like hint for this one would be to find the midpoint of AC and BD. I cannot write today. I literally just wrote the two letters backwards. BD. I literally said BD and wrote DB. Okay, anyways. So I'm going to find the midpoint of that. Midpoint is an XY point, just like the vertice points from above. And so the midpoint of AC is going to be, it's the two X values added together. and then over 2, and then comma the two y values added together over 2. So it's going to be -1 plus 5 over 2, comma, the y values, 6 plus -3. Sometimes I just write 6 minus 3. You're welcome to do that, but I'm writing it to make sure we have the formula. Over 2. So I'll do a quick refresher here. Midpoint is x1 plus x2 over 2 and y1 plus y2 over 2. But like I said, that should be in your theorem and postulate book, so it shouldn't be an issue anyways. So when I do this, the midpoint then, that means -1 plus 5 is 4, so that's 4 over 2. If you want to go ahead and reduce it in one step, you can do that. 6 plus -3 is the same as 6 minus 3, so that's 3 over 2. So then that midpoint is 2, comma, 3/2. So if BD has the same midpoint, then I will know it bisects, and thus these are parallelograms. So the midpoint of BD is going to be 3 plus 1 over 2. And then the y values, 5 plus a -2 over 2. So 3 plus 1 is 4, so that's 4 over 2. And then 5 minus 2 is 3 over 2, so that's 3/2. And so this ends up being 2 and 3/2 again. So because these are the same midpoint, they bisect, and thus it is a parallelogram. So that's one way that I could find this one. I'm going to use the same points and use another method in just a second. Are there any questions about this method? Or any questions about midpoint?
It's a lot.
Once you get the hang of it, it's actually not that bad. Especially when it doesn't specify which one you have to use. I probably am not inclined to use this option as my first choice. Not because it's mathematically hard. It just, I don't know, it just seems like a lot more work than the other stuff. I don't know.
Also, I'm pretty sure A is supposed to be top left, B is supposed to be top right, and C is bottom left, D is, or no, C, D, R.
It might be. As long as they're not A and C beside each other, it should be fine.
Yeah.
But yeah, if you actually plot them, I probably do need to rotate it, but it's fine. 24. So this same points, but we're using theorem 6.10. Okay, so my little hint for this one, or what we're gonna do, is we need to show the opposite sides are both congruent and parallel. Alright, so to show that my opposite sides are, I'm going to do parallel first. I need to prove that they have the same slope. Okay, so as Michael pointed out, my pictures actually needs to be rotated. But either way, they're still not putting A and C beside each other. So I need to find the slope of AB and the slope of CD, or I need to find it for BC and AD. Okay, so anybody have a preference? Do you want to find the slope of BC and AD or of AB and DC? Somebody pick one.
A, B, and C, D, I guess.
Okay. All right, so we're going to find the slope of AB first. So the slope of AB is going to be, my points are not visible, so I'm just looking at the points off the book. So slope is, we'll just do a quick refresher, y2 minus y1 over x2 minus x1. So for B, y2, so it's 5 minus 6 over 3 minus a negative, so that's going to be plus 1. So that's negative 1 over 4. So that's AB, and then I need to do CD. So the slope of CD is going to be y2 is negative 2 minus C is, or the y point of C is negative 3. So minus a negative, so that's going to be plus 3 over 1 minus 5. So that is 1 over negative 4. Now, even though on the top one, the negative's on top, and the second one, the negative's on the bottom, the negative, it's still that the whole number, the whole fraction is negative. So these have the same slope, so these are parallel. So I've shown that they're parallel. Now I'm going to go down, and I need to show that those same sides are congruent, okay, using the distance formula. So the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So the distance of AB is the square root of 3 minus a negative, so minus 1, or sorry, plus 1, squared plus 5 minus 6 squared. And so then that's the square root of 4 squared is 16 plus negative 1 squared is 1. So that means that's the square root of 17. So if then the distance of CD is equal to the square root of 17, with the information that I have, I'll be able to show that they are, or this is a parallelogram. So the distance of CD is the square root of 1 minus 5 squared plus negative 2 minus a negative, so plus 3 squared. And then work this down. 1 minus 5 is negative 4. Squared is 16. Negative 2 plus 3 is positive 1. Squared is 1. So 16 plus 1. So that is the square root of 17. And so that means that those sides are congruent. And so then that means that since AB and CD are congruent and parallel, ABCD is a parallelogram. Any questions about this stuff? So in 25 and 26, they're going to give you a set of, like a new set of points. You can choose any method to do that. So you can use one of these two that I just did for you. You can use one of the ones that was in the PowerPoint that we kind of briefly looked at, or, you know, if there's a method that wasn't listed and that we haven't used, you're still welcome to use that as long as it's like follows one of the theorems or the definition of like a parallelogram. Okay. So I'm going to give you the problems, and then I'm going to give you a couple little hints for the three, for like how to do them the way that I gave you these here. So problems are going to be 9 through 19 odd. Oops. And then it's going to be 21, and I'm writing them this way so I can write a thing beside them. 23, and then 25. So for 21, that's theorem 6.6. And so I would show pairs of opposite sides are congruent by the distance formula. So that means with that one, you're going to have to show that like how on this previous one we showed that AB and CD were congruent, you also would have needed to show that BC and AD were congruent as well. Okay, so you'd have to do it, basically you'd have 4 distance formulas in that problem. So I'm gonna put that there's 4 of them that you'll have to do. 23 is by the definition of a parallelogram, and so to do that, or to use that, you have to show both sets of sides are parallel by finding slopes. So you'd have to find the slopes of all 4 sides. Again, in the, it wasn't this, oh yeah, it was this one. We found 2 of them. You would need to find the other 2 as well and show that both sets of opposite sides have the same slope and thus they're parallel, and that's the definition of a parallelogram. Okay. And then 25, choose any method. Choose your favorite one. Choose the easy one. Or choose the hard one. I don't care. All that's relative. Whatever you think. Any questions? All right, so we don't have as much time as we've been having, but you have some time that you should be able to knock out a decent amount of these today. You'll have some time tomorrow to work on these. We have a quiz on Friday. And so with that, you have the quiz review is at the end of this chapter. It's only 4 questions, so we'll have some time to do that tomorrow, and to go over that as well. And then you'll have your quiz on Friday, and then I'll probably give you some time to work on your vocab after that, because your vocab is due on, I think that date technically might be for Monday, but I realize we don't have school on Monday, so it'll be for Tuesday.
Go to the office.